Hello everyone, welcome back. This is Engineer Hussein Osapi. So in this video, we'll be looking at the sum of an arithmetic progression, like we love to call it, APs. Alright, so in this video, we'll be looking at some basic things we need to know about the sum of an AP and also deriving it. Alright, so before we begin, do not forget to like and subscribe to the channel. Alright, let's look at it. Okay, so the first thing I want us to understand is how we can derive the formula for the sum of an AP. Now, the sum of an AP is given by the formula S sub n is equal to n over 2 open square bracket then 2a plus open bracket n minus 1 close d. Alright, so one thing I want you to understand is that when you look at the sum of an AP, you want to find literally the sum of all the terms that have been given in a particular sequence. So this will be a series. Let's say, for instance, I've given you something like 2, 4, 6. If I say, find the sum of the first 3 terms, all you have to do is to add 2 to 4, then whenever you get to 6. So 2 to 4, that gives you 6, plus 6, that's 12. So the sum of the first 3 terms is basically 12. But now time comes where you have to have, or maybe where you end up having numerous terms. Let's say I give you only 2, 4, and 6, and I ask you to find the sum of the first 50 terms. Now let's face it, we don't have 50 terms here, we only have 3 terms, and let's say it keeps on going recursively. We can determine the sum of the first 50 terms just by using this particular formula in question. Now, the most important thing that we need to do first is to understand how we can come up with this formula that we have. But as you can see, it's quite easy to remember. It could not be easy to everybody, but at first glance, most of the things are quite difficult. But if you keep on practicing, getting to write these formulas over and over again, you get a hang of it. As you can see, there is this part in the formula which just represents the nth of a sequence. The a plus open parenthesis n minus 1 close then common difference. This is just the formula for the nth. The only thing that has been added is n over 2 then times 2. Let's understand that. Okay, so let's see how we can come up with this. So the first thing I want you to understand is how to solve any sum of an AP without even creating the formula itself. So I want us to look at how we can find that numerically. Let me say using numbers. Okay, so first thing we're supposed to do, so let's say method 1. Now the first method won't really give us a formula, but it just gives us the answer directly. So let's now define some things. Let's say, for instance, we're trying to look for the sum of the first 100 terms. Let's say finding the sum of the first 100 terms. And let's say, for instance, our sequence is given in a manner where we just have, let's say, 1 to 100. So let's take, for instance, we're having 1, 2, 3, 4, and it keeps on going. I'll say reach 98, then 99, then 100. Let's take this for instance. So if we have this, basically what we need to understand first is that when finding the sum, we want to see what we will get when we sum up all the terms. Now be mindful that this is an ellipsis. So ellipsis must show that it's something that's supposed to be there but it's hidden. So if I was to find the sum, what are we going to do? So we need to understand that whenever we're using the first method, which is the numerical method, let's say numbers, what we'll be doing is that we'll be summing them up. So the first thing we're supposed to do is literally just write them in sum format. So we're going to say the sum is equal to 1 plus 2 plus 3 plus 4 Then we could say plus dash 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 plus 98 plus 99 plus 100, like that. So this gives us the sum that we want. So after you write the sum, all you need to do now is to write it backwards. What I'm trying to say is that I want you to write it like this. So S sub n is equal to, I was ascending from 1 to 2 to 3 to 4 to 100. Now I want to descend the entire statement from 100 to 1. So this would basically be, so if I have 1, 2, 3, 4, 5, then I'm supposed to also have 5 this side. So let's just also add another number. Let's put 97. Yeah, just to make it balanced. This does not change anything. Please be mindful of that. It doesn't really change anything. The statement still follows to be the same. So you write it like that, and then we have to write it. It is in descending order. So we're going to have 100 plus 99 plus 98 plus 97, and plus ellipsis, plus we get 4 plus 3 plus 2, then plus 1. As you can see, now I added the 97 because I wanted to balance the terms. As you can see, the values I'm having this side are equivalent. This with that, that with that, that with that, and just like that. Same thing on the other part. I'm having same terms, same values like that. There is no term missing a pair. So after doing that, the next thing we're supposed to do is to sum up what we have. So if I say, let's add top to bottom, what are we going to have now? So let's say plus S sub n plus S sub n, we have 2 S sub n. Now what is 1 plus 100? That is 101. Then plus 2 plus 99, also 101. So it's going to keep on coming out to be 101. So this also gives us 101 again, plus 101 plus dash 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 plus 97 plus 4. That gives us 101 again. Plus 98 plus 3 again, that will give you 101. So it just keep on going as 101, as you can see. Now that we have that, as you can see, we can end up changing the statement in the sense that since we're looking for S sub n, all we can do next is to find the value of S sub n. As you can see, is to find the value of what? S sub n. Now, since the sequence ends on 100 terms, we can say 2s sub n is equal to 100 terms times the constant sequence value, which is 101, which is what we're having here as a constant sequence value. So 100 times the constant sequence value. And after that, what we can do next is that since we have 2 S sub n being equal to 100 times the constant sequence value, which is 101, all we can do is to make S sub n the substitute formula. So I can divide throughout the equation by 2. That eliminates the 2 I'm having to sub n. So I'm going to have S sub n is equal to now 2 into 100, that will give me 50 times 101. So S sub n is equal to 50 times 101, and I have 50, 50. 50, 50. We're going to have that amount as our sum of the first 100 terms. So this value we're having here is what we're referring to as the sum of the first 100 terms. 100 terms of an AP. And that was the AP we chose. So if at all you want to demonstrate how to come up with the sum of an AP using numbers, it's best to just go with this approach. Questions might be given depending with the person who is giving you a lecture, and they might say, find this using that method. So it just depends with you. Now let's try and get the formula. Since this is a numerical way, numbers always give us numbers. If we use letters, yeah, we'll expect letters in the end. So in method 2, we want to come up with the formula that is in letter format 9. Okay, so letters. Okay, so now whenever we're using letters, we have to define some terms. We just can't bring up random letters in our head and say, okay, this will work. But if at all you define those variables you're using, you will still be marked. But let's just do something that is common. So let's define the terms. Okay, so we know that we want to end up having S sub n is equal to n over 2 open square brackets 2a plus open parenthesis n minus 1 d, just like that. So now this is what I want, isn't it? So let's define some terms here. So we need to understand that. So we say where a is equivalent to the first term, then n is the number of terms, then d is common difference, as you can see. So n represents the number of terms, d is the common difference, just like that, as you can see. Okay, so all right, so since we have it like that, then we're going to say that the sum S sub n is equal to a plus d plus a plus 2d plus plus a plus n minus 2d plus a plus n minus 1d, just like that. Now remember, using the same method, it implies that we have to write it backwards. So we have S sub n in descending order will be a plus n minus 1 d. Then we'll have plus a plus open parenthesis n minus 2 d plus plus a plus 2d plus a plus d plus a. Alright, so if we add this, we'll be having 2 S sub n. Now remember, these things are supposed to come out the same. So we end up having constant terms. We end up having 2a, because n plus a is 2a. So I have 2a plus n minus 1 d. And this statement will repeat on being the same throughout. Plus again 2a plus n minus 1 d plus plus 2a plus n minus 1 d plus, I guess you get the point, just keeps on going just like that. Now since n is a number of terms, remember it is the number of terms you want to find in the sum times a constant value. So 2 S sub n is equal to n times the constant value 2a plus n minus 1 d. Now remember, looking for S sub n, so we're going to multiply by half, which means dividing throughout by 2. So the 2 cancels with that. So we have S sub n is equal to n over 2 open square brackets 2a plus n minus 1 d. And we have derived. If we're told to show it, the other means shown. Alright, now I know this could be a handful at first glance, but with a little bit of practice, you get a hang of it. Alright, thanks for watching. If you have any queries, you can reach me up on WhatsApp on the line 077 149 5252 +26 then that. Alright, remember, slow progress is better than no progress. And let's strategize before becoming a statistic. Let's try to push for that A+.